Hello everyone, this is Florian and today's video is about the built-in slice function. Before we can have a look at the built-in slice function, we first need to understand what slices are and when to use them. Therefore, we will first have a look at a practical example on how to solve the given task using the index operator. Subsequently, we will see why it is beneficial to use the built-in slice function. Without further introduction, let's jump in. So first, I create a new REPL session. This time I'm using BPython to get a little bit more syntax highlighting. You can install it via pip install BPython, and it has the same look and feel than the built-in REPL that comes with every Python installation, but again, add some syntax highlighting. All right, so suppose we have a function returning a tuple as follows. So first we need the random module from the standard library, and now we define a new function, get product code. And what it does, so we have a list of products, so product, and here we go with list. And each product has a product code, and in this list only product codes are presented. Each product code consists of two parts. The first part are 3 letters indicating the type of product. So for instance, com for something like computer, followed by an underscore, and after the underscore we have a 4-digit number. So for instance, 1, 2, 3, 4, and this is already a product code. And let's add another one. So let's say com underscore 1724. And now something of a different product type. So let's say phn for phone, for instance, underscore 0012. And let's add a fourth one, which is phn 7125. So this is our list of products, and we want to return one of the products randomly. Yeah, so return random.choice of products. All right, so that's all what our function does. So if we invoke it, get product code, then we get one randomly back. In this case, it was already the first one. So now the goal is to properly parse these product codes. Yeah, so for instance, get first the product code, the product type, and secondly the product number. So there are different ways to represent these types of codes and parse them properly. But let's go with strings here as shown above. And to retrieve the product type, you can use Python's index operator by appending brackets at the end of our variable. Yeah, so first we need a product, so product equals to get product code. Now we have a product, or let's get a better name, product code equals product. So product code is a better variable name. All right, so here we have phn underscore 7125, and I would like to retrieve the type of product, which is phn, and I can do that by using the index operator, so brackets after it. And now I'm interested only in the first 3 characters, so I can write something like :3, which gives me the first 3 characters. The index operator, so the brackets, accept 3 numbers separated by colons. So the first one is the start index, it defaults to 0. Then we have the stop index. In this case I have the number 3, so this here is equivalent to the one above. And it's important to note that the index 3 is exclusive, so the third index, in this case it would be the underscore, is excluded. That's why it's not inside of the resulting string. And the last number it accepts is the step size. This one is also optional, and by default it is 1. So this means that every character is used. We can also specify a step size of 2, which means that only every second character is returned. In this case, we would end up with p and n. And we can also use negative numbers. So if we have a negative step size like -1, we get an empty one because it tries to go backwards. So start at the start index, and then go backwards till the stop index is reached. In this case, we are already at the beginning, so the number 0 or index 0 is the last index that we can access. That's why the string is empty. We can do something like start at the third index and go to the 0, 1 and then -1, and then we have a reversed string. So now the question arises, why is this actually a bad approach? So using magic numbers as we're doing here, so 0 and 3 and -1 or 1, these are called magic numbers because if you have a look from the outset on the code, you're not actually able to understand what these numbers stand for. That's why they are called magic numbers. And to add a little bit more meaning to the code so that you do not forget after 3 months what does this number 3 stand here for, because you don't know that you need the first 3 characters to access the product type. You can make use of the built-in slice function to get a slice object and assign it to a variable name, give it a more meaningful name, and this way your code is much more documented. So let's have a look at a practical example first. So how would we change our first example? The function does not really change, so we can leave it as it is. We need the random module, and the function is as it is. There's nothing that we can change about it. But what I would like to create is a slice object and assign it to a proper name like product type slice or product type slice. This way I indicate that this slice is used to retrieve the product type of a product code. And what we need is slice 3. This is the very same thing as specifying :3 in the index operator. So I'm only specifying here the stop index. And now I can do something like my product code that I randomly retrieved from the function. You remember phn_7125. If I now use the index operator, but not use the magic numbers, but instead the slice object, so product type slice, then I get phn back again. And that's the basic idea. Instead of using the magic numbers, create slice objects that you can share across your code base or with other people and add a little bit more meaning to your code. So what can we do with the built-in slice function? Well, in essence, it accepts the very same parameters than the index operator. So slice can have a start, a stop, and a step size. So if you only pass one number to it, it means that you only specify the stop index, which is again exclusive, so it's not included, but it stops there. If you specify 2 numbers, that means that you're specifying the start and the stop index. And if you're passing 3 arguments to it, it means that you are specifying a start, stop, and step size. So for instance, slice 1,3,1 would return the h and the n. So if we pass this one to the index operator, so product code index operator and closing bracket, and we get back hn. And again, we can also specify negative indices, like starting at -1 and go on until -3, and the step size is -1, and then we get the 5 and the 2 from the 25 at the end, right? Because we are starting at the last index. And then 3 back, -3 is over here, it's exclusive, so we get only these 2 digits, and -1 means that they are reversed because we're starting here and going over in this direction. Alright, so that's basically it, what you need to know about the built-in slice function. Stay curious and keep coding.